All right, great. So we're going to talk about trust. And let me tell you a story. That's basically me vibe coding my application here. Claude Code spent 4 hours. Very impressive code coverage, 95%. There are a lot of files modified, and you know, it was quite an expensive experiment, but I was generally pleased. Those are good metrics. And I'm like, great, now let's run it. And yeah. And I was like, but I have 95% coverage. I have how many tests? Not this. This shouldn't be here. And then I'm like, okay, let's look at the test runs. I have a lot of tests. Yeah. So we're going to talk about that. I want to start with something else. I want to define a concept of what is called intent to code chasm. Intent to code chasm is the difference between what we have in our minds and what end up in code. This chasm always has been there. It's not new with AI, it's not new with vibe coding, it's always been there. And we're going to talk about how we bridge this chasm, what's the important parts for it, especially in the context of AI-assisted code, but not only. So AI-assisted code, as you saw in my opening, is not great. And it's measurably not great. I bet you heard about it, and there are by now, what's going on? Allow Python to find devices on local network? Sure. I mean, what can possibly go wrong? Okay, that was not part of the demo, but it's perfectly fit. All right, so 1.4 more critical issues, 1.7 major critical issues, like critical and major. I mean, it's not great. I have some agent running in the background, Python trying to find devices on local network. I mean, what can possibly go wrong? Research from last year, more or less a year ago, from a great folks of Sonar, found something interesting. Right, so we have this benchmark of how great models write code. And every new release, everybody like, oh, we solved coding. And Sonar, what they do is they measure code quality. And they said, okay, looks like the models are really great. Let's see if the code that they generate is really that great by the good old metrics of software engineering. And the fascinating find here, it's a little bit small, I will read the key phrase to you is, this study found no correlation between models' functional performance, as measured by benchmarks, and the overall quality and security of generated code. So the benchmarks are great, the code quality, security, no relation. That's interesting. And you know what, we all experience that. So this is another study done by great folks at Kodo that kind of correlate two things. The hallucinations that you observe in the code and the trust, the confidence that you have in the models. And more than 65% of us are in this quadrant of seeing a lot of hallucinations and not trusting AI. I mean, let's do it right now. Who is there in this quadrant? Seeing a lot of hallucinations and not trusting AI? Yeah, 76.4, exactly. Yep, exactly. And I mean, we mentioned code quality, but also security. You see this hockey stick of APIs that just don't have any input validation or authorization. And you go like, what? And like, yep, that's a 1,000% increase in APIs that missing input validation and or authorization. That's impressive. That's scary. So models get better year over year, but we actually trust them less and less. This is a funny survey from Stack Overflow, and Stack Overflow is basically by now 5 people that passionately hate AI. But still, it's an interesting number. This is 2024, and you can see here that someone distrust and highly distrust was around like what, 30%, 22 plus 8, around 30. And this is 2025, someone distrust and highly distrust is suddenly 45. So it's basically doubled, right? And the models got better. We should actually trust them more, but we actually trust them less. So we trust them less, and this is not Stack Overflow now. 96% of developers do not fully trust AI-generated code that is functionally correct, right? I mean, almost everybody knows that we cannot blindly trust AI-generated code. We use them more. You can see that the share of AI-assisted generated code actually going up. 65% is a lot. It's a prediction for next year, but we can say maybe it's it's actually going to be more than that. So we trust them less, we use them more, and we check them less. You can see here that only 48% of developers always check their AI-assisted code. Come on, what's going on? My agent is doing something very deliberate, right? So 48% always check their AI-assisted code. It means that 52% does not. Trust them less, use them more, check them less. How that makes sense? It does not. My name is Baruch Sadogursky. I'm J Baruch everywhere on the internet. I call myself context sommelier because, as you will learn today, context is what makes all the difference between good and bad AI-generated code, and knowing how to correctly use it is the key for everything that we are doing now. Started with Java, did a little bit of DevOps, Java champion, Microsoft MVP for AI. None of that relevant. What's relevant is this. Show notes, the most important slide of this talk. If you go to speaking.jbaruch, and thank you Switzerland for the domain, you will find the slides that are already there, the video that I'm recording. Am I? Yes, I am. And all the links for everything, including all the research that I mentioned earlier. It's all there. Conveniently on the bottom of every slide, together with the hashtags for Voxxed Luxembourg that I'm sure it's trending since the keynote. You also have the QR code here that goes directly to the page and is going to disappear in 5, 4, 3, 2, 1. It's right here, it will come back, no worries. Okay, so models are improving, there is no doubt about it. LLM code editing skill by model release date is going definitely up and to the right. Better models, no doubt about it. The AI generated applications still suck, although models are getting better. So why? Let's try to understand. To understand why this happens, we need to understand how software starts, generally. How software begins. What's in the beginning of software? And I would claim that in the beginning of software is our software design documents or product definition documents, or call them whatever you like. So some product people sit, maybe talk to the customers, maybe talk to the business, maybe just like sleep on it and come up with, whoo, this is how software should look like. And the one problem with those documents is that they are write once and read maybe once. Maybe. And the question is why? Why those software documents are, according to all of you, I have no doubt, are so disconnected from the reality and from what the software eventually looks like. One of the reasons is human language. Now, here is a great AI model. From Mistral, their like application code, Le Chat. As an English speaker, I'm giggling because it's like le, like French, and the jet, like English. And you look at that and you see a cat, which is adorable. I love this pun. It's great, but it's coming right to this point of human language is extremely ambiguous. Not only between languages, even within the same language, we have tons of different meanings to the same words. So, any human language is an obstacle in understanding. When product people say something, we can hear something else entirely, not only because of language barrier, but because any language is ambiguous within its own. Now, by the way, if you didn't know, Mistral renamed the adorable, the amazing Le Chat to Vibe 2 weeks ago. I have a personal issue with that, because vibe coding is exactly the opposite of what all this talk is about. We're going to talk about that. Right? So yeah, so language is problematic in expressing ideas. On top of that, we generally are not very good in expressing ideas. Whoever was in university might remember this amazing effect. You come in and kind of the professor starts like, hello, good morning, and you're like starting to doze off because there will be like 3 minutes of introduction, and then after 60 seconds you look at the board and you see this. And you're like, oh, what happened? How did it get here? I have no idea what are you talking about. And this is because your professor probably had what is known as the curse of knowledge. Now, curse of knowledge is a cognitive bias that basically means once we understood something, it looks trivial to us. And once it looks trivial to us, we don't bother to explain it because, well, it's trivial. Now, there is the other opposite of curse of knowledge, which is mansplaining, when we will work very hard to explain something that is very, very obvious. And the problem is to know the difference, which is impossible. Because, as I mentioned, whatever is in our head sounds trivial to us, so we need to force ourselves to explain something that is trivial. Now, literally, I have no idea now whether I'm successfully battling the curse of knowledge or I'm mansplaining about curse of knowledge. I don't know. Maybe all of you know that and it sounds trivial to you and you're like, ah. Or maybe you're like, oh, I didn't know about that. But I have no idea, I don't know. And this is very tricky for us, for humans, because we don't know what deserves an explanation and what's not. And this is very true for communicating about software as well, right? So, yes, okay. So why the documents, those software definition documents, those PRDs, don't work? So human misunderstanding and curse of knowledge plays a very big part of it, right? So we read something that is written there, but there is something that is missing from there because they thought it's obvious when it is actually not. And that basically means that context is not shared. Whatever is in the head of those product and business people is not shared with the developers in any way that is clear to the developers. And there are fuzzy responsibility boundaries. Who remembers that? That was kind of a thing like 20 and 15 years ago. There was like some animosity between the developers and the testers. Who's old enough to remember this? Yes. Who now actually agrees that this is true? Well, almost no one, and because this is not true, right? The testers are definitely not in any kind of conflict with the developers. They actually help the developers to produce better software. This is what everybody wants. So the testers are our best friends and we are very happy with them. And then who remembers this? Right? This is kind of pre-DevOps. This is the reason why DevOps kind of was born. right? Because there was animosity, because developers and ops, whoever wrote books like the Phoenix Project, for example, knows exactly what's described right there. This is exactly the point, right? It's the developers and ops and the fight between them solved by DevOps. Now this is very real. This is very real and it happens all the time, and there is a lot of blame going on. We end up with a feature that is not what the customer needs. There are a lot of blame to share around. Whether it's the product that didn't define it correctly, whether it's a product that didn't convey it correctly, whether it's a developer who didn't understand or just didn't do the right thing. So there is some dynamic here that is problematic still, and we don't have a solution because the problem, as we just spoke, is very human, and this is something that we'll have, and there is nothing we can do about it. So that's a real problem. We have a trust problem, not only with AI. We didn't speak about AI. All we spoke about is human interaction that brings this trust problem. And the next thing we know is that this is where we live. Think about it, probably very true. You can get very, very excited about software until you know it really well, and then not so much. There are exceptions. What? WinRAR, probably. That's pretty much it. Okay, anyway. Eventually we do have working software, sometimes, somehow. How? What helps to actually bridge this gap that we have? First of all, good intentions. Eventually all of us want to write good software. So we will use our professionalism that we all share to actually overcome those issues when they arise and fix them, right? And obviously we have test and QA, we spoke about that. They help us solve those problems because they are additional layer of defense for all those misunderstandings and trust problems. And there is end result observation, right? We write software, we look at it, and although we are not product people, but we can still try to assume whether it's the right thing. And obviously, we do have a common-ish context. Yes, it's not perfect, but it's definitely there. We went through all this process of explaining what our software needs to do, and we kind of understand it even if it's not perfect. But now we have generative AI. And generative AI doesn't have any intentions, obviously. It doesn't have any professionalism, it just guesses the next word. It doesn't do any tests or QA. As you saw, the tests are assert true. It cannot look at the results and understand if that's what we want it to do, and it doesn't have any context at all. So, I mean, what can possibly go wrong, right? And the lack of context is exactly the intent to code Chasm. That's exactly the problem. And it's much worse with LLM because LLM doesn't have any context out of the box. When we ask it how to use Spring Boot, it will tell us, I have no idea what you're talking about. My pre-training was about Spring was that it's a season and I have no idea what are you talking about. Whatever AI manages, whenever AI manages to understand, but you meant a framework by mentioning Spring Boot, this is the context that has been artificially added to AI. Without context, that's the result that you are going to get. And it's actually even worse because generative AI, LLMs, are by definition non-deterministic stochastic systems. For the same prompt, you will get slightly different results by design. This is how it should be. It's absolutely fine when we chat with it. We actually prefer slight variations in responses because it kind of mimics human interaction, which makes it fun and relatable and nice. But with code, this is a huge problem because there is no almost correct code. Code is either correct or incorrect, so those slightly different results actually hurt a lot. And what these slightly different results remind me is the infinite monkeys theorem. You probably know it. The theorem goes that if you give to infinite amount of monkeys, infinite amount of typewriters, given infinite amount of time, they will produce the full corpus of works of Shakespeare. Which actually makes sense. LLMs are exactly the same. We gave them GPUs instead of typewriters, and they have a slightly better than random chance of outputting the right thing. But still, given not infinite, but huge number of interactions, sometimes they will produce the right code, Shakespeare. Sometimes they will produce code that will look right, Shakespeare-ish, and sometimes they will produce just gibberish. So, who remembers Back to the Future movie? Okay, there was Mr. Fusion engine there. How did it work? What do you put in? Garbage. What do you get out? Energy. LLMs is the opposite. You put in a lot of energy and the output is sometimes Shakespeare, sometimes garbage. So that's the inverse Mr. Fusion for you. So yes, monkeys typing our code, sometimes hitting the right thing, sometimes not. So, I mean, what can possibly go wrong? And then you say, you know what, it's fine, no worries, this is a good point to get started, we will review all the AI-generated code, and I'm saying, sure. Code reviews suffer from looks good to me syndrome. And looks good to me is obviously not only for reviewing AI-generated code. Looks good to me happens a lot when we review other people's code for, again, very, very human reasons. We are busy with other stuff, and we need to switch context to do code reviews, and we generally don't like reading other people's code. Which includes, by the way, our code, which is 6 months or older. But we definitely don't like to read generated code. I mean, what was the last time you passionately reviewed bytecode generated by your Java source? I guess never. It's generated code. Why would you bother? This is the same idea. You don't want to review generated code because what's the point? And you're busy, and it's kind of not interesting, and it's meh. And the result is, well, looks good to me. So generally, AI coding agents don't do a very good service to software quality. So yes, as I said, my name is Baruch and I have an obsession. And my obsession is exactly that. Intent to code Chasm, and how do we bridge it? How can we make sure that the code that is generated by AI is what we have in mind? And it looks like the industry kind of find a solution. You probably heard about it. It's called, what does help? Spec-driven development. Who heard about spec-driven development? Okay, not enough people, but I will explain to you right now. So the idea of spec-driven development, which is all the rage now, you can see Martin Fowler writes about it on his website. And ThoughtWorks is now on the radar of ThoughtWorks in an assess category, which is like, hey, you should learn it right now. And this is from GitHub, from Microsoft. They have a framework for spec-driven development. There is another very popular framework called OpenSpec about spec-driven development. Amazon released an entire IDE for spec-driven development called Kiro. it's really all the rage, right? What else? Zencoder has an IDE for spec-driven development. And you know, if Andrei Kapatit posted about it on X, that means it was the real deal. And he did. And he actually like passionately supports spec-driven development. So it looks like we are bridging the prompt to code chasm. How does it work? I promised you spec-driven development in 30 seconds. Here we go. Software definition documents, or PRDs, are the prompt. We feed it to LLMs, and then we ask to create a spec. And a spec is what AI understood that needs to be done from those documents. The specs are human readable, so we all read them. The developers, the product, the business, we all iterate, we fix stuff that AI didn't understand or lacked context until the specs look good to us. And then, yeah, so everybody expect and approve. And then we kind of ask LLM to implement this spec, and we get allegedly what we actually meant in phase 1. So, problem solved? Well, yes, but actually no. And it's not solved because spec-driven development only gets you so far. It nails the spec by iterative process, which is great. But once the spec is written, we basically do this. We say like, okay, here is the spec, write the app. And then we're back to the same problem. It's now not intent to code chasm, it's now spec to code chasm, but the chasm is still there. We didn't bridge the entire thing. We have no guarantees that the app that we have there actually does what needs to be done. And the problem is stupid monkeys. Now we have those monkeys not dealing with the entire bridge, but dealing only with the second half. From the spec to the code, it's all monkeys. Which is not great, because if you want to remember one thing from this talk, is this: never trust a monkey. When you deal with monkeys, you have to validate and verify everything that monkeys do. So let's see. What is created by whom, and what can we trust? So we have a prompt. It is created by humans, and you remember all the biases that we spoke about cannot be really trusted. And then we can spec, generated by monkeys, definitely cannot be trusted. And then we have code generated by monkeys, which is also cannot be trusted. So, I mean, not great. Okay. Now we're going back in history. The year is 1980, I want to say 6 or 8, definitely not 9, way before. The place is Reykjavik, Ireland. Chairman Gorbachev meets President Reagan, and they talk about nuclear disarmament. And the Soviets go like, sure, trust us. We are going to disarm all our nuclear arsenal. And then Reagan goes like, well, доверяй, но проверяй, which means test by verify. Basically, it means, sure, we trust you, but let us take a look. And this is exactly what we need to do with monkeys and humans, by the way, right? So let's see, how can we verify them? The prompt is created by humans, but as we spoke, it's human readable. We can verify it by other humans. Many people can look at it and see if it's good. The same goes with spec. Spec is generated by monkeys, but it's human readable. We still can look at it and verify it. Now the code is generated by monkeys, verified by code reviews, which means it's not verified. So, I mean, not great, not great. We still have a huge chunk that is not verified. If only there was a way to ensure the code does what it expected to do. Any ideas? Testing! testing are the guardrails for monkeys as well. We can write the test first, for example, how that is an idea, and then we can add LLM, implement the code until the tests are passed. And if the tests pass, we can actually be sure that intent is captured correctly. What an amazing and innovative idea. Looks familiar, anyone? Test-driven development, thank you very much. Test-driven development looks great. So now we have tests that is generated by monkeys and verified by humans. And then we have code generated by monkeys and verified by tests. That looks great, except of this little thing. Tests verified by humans? Not so much. I mean, humans are not really good in doing test-driven development. Who really practices test-driven development here? Okay, like 5 hands, but truly, like, yeah, don't lie. Okay, all right, okay. Not a lot. And not a lot for very obvious reasons. Developers are biased for action. What do I mean by that? We are all in this space for dopamines. Everything we do is for dopamine, including writing code. How writing code gives us dopamine? Well, we are excited about software that we create. Because there was nothing, we typed some buttons, and there is something. And we go like, ooh, it works. We want to do the happy path. We want to solve the problem. We want to write the code. We don't want to start thinking about stuff like exceptional cases and start with tests. We want to go and solve the problem. We already have the solution in our hands. We want to solve the problem. And we don't like read code, and we definitely don't want to read tests. That's even less interesting. So this is the real deal. We don't read the tests because it looks good to me, and then the code is verified instead of validated tests by look good to me of the tests. And we end up with exactly the same problem of trusting the monkey, which is not great. So let's try to look at it from a different perspective. What I want to do is to verify the tests and the code somehow without resolving to trust the monkeys. And what are tests? So we have setups, and we have mocks and stubs, and then we have access right inside our test. Think about integration tests that you're writing. And eventually we have assertions that like whatever we were testing was true. What out of those actually needs to be verified? Not the setup, not the mocks, not the access. We need to verify the assertions. We need to make sure that the assertions are correct and they run and we can trust them. Now, when I say assertions, that sounds familiar again. It again takes us 20 years back to Martin Fowler coming up with, not 20 actually, 15-ish, talking about, first time, about behavior-driven development, BDD, suggesting that we can express our assertions in a domain-specific language, given when then, that looks something like that. We have a feature, user trade stocks, we have a scenario, given I have 100 shares of stocks, whatever, and the time and like the trade windows is open, when I ask to sell shares, then I should have those results. Now, this is interesting because it, as opposite to tests, this is completely human readable and actually can be written by humans. So if we shift from validating by tests to validating by specs, looks good to me applies much less, because reading that not only is less cumbersome than reading code, we can actually ask people who have the intent, product and business, to read that and tell us if we captured the intent correctly. Right? Now this is BDD in action. The only problem is who writes the specs. Now, in theory of BDD, by Martin Fowler, business people and product people should write the specs. And business product people will say, no. We have our own standards of PRDs and software design documents. There is no way we're going to write this gibberish for you. And then it's up to developers to write the specs. I mean, we had a hard time writing and reading the text. The tests, which is code. Why would we bother writing the specs, which is not code? So, Gherkin is plus Cucumber is the implementation de facto of behavior-driven development today. It has human-readable and machine-parsable specs, which allow us to generate tests out of specs without monkeys, or humans for that matter. So now, if we find a way to generate the specs, everything from the specs down is automated, and we took monkeys out of the loop. So this is what happens now. We have prompt, which is created by kind of monkeys and verified by other kind of monkeys. So this is fine. We have spec, generated by monkeys, verified by readers. Now, can I trust monkeys to generate my spec? No, right? Because never trust a monkey. But the spec is human readable, and it's not code. People will read the spec because we can ask product people and say, hey, does this look what you wanted to happen? And they might say, yes, it captures my intent, or it might say, no, we need to change something. And maybe the change will be in the PRDs because the PRDs weren't clear enough, and we will regenerate the spec, and we will reread it, and then we can approve it. So although the spec is generated by monkeys, it's actually verified by humans, and this is fine. And then we have tests. Tests now deterministic, generated by machines from the spec. No need to verify, no monkeys involved. And then obviously now we're making progress. Now what we need to do is make sure that the code adhere to tests. Now it is a problem with monkeys because monkeys will do what monkeys do. They will change the tests to pass on the code that they generated. They're definitely going to do that. The only way to prevent that is to make our generated tests read-only. Now this looks like we're closing the loop. Now the monkeys cannot tamper with tests. And that means that they have to write the code that actually solves the test until the tests pass. Otherwise, the problem is not solved. Looks great, doesn't work. And it doesn't work because in order to, and the 5 people that practice test-driven development will tell us that when they write the test first, they will still have to adjust it later. Because the code dictates realities, technical realities, that force the test to change. For example, we need to test the setup, we might introduce some new mock-ups and stubs, we might deal with access of fields and variables. And this is fine. This is allowed to be changed in TDD. The only thing that is not allowed to be changed are assertions. Now, if we lock the entire thing all the tests, just make the test directory read-only, the monkeys will burn a lot of your money. And after a month of working, will say, well, I give up. Because without changing those, it's impossible to actually get the test to green. And this is what we want. So we need to find a way that will allow those to be changed, but won't allow the assertions to be changed. And the way to do it is actually let them touch the test files, but hash and verify the assertions themselves. We never trust the monkeys to do the right thing, but we allow them to change the test files, and then in the end we just compare that the assertions weren't tampered. So problem solved? Well, almost. We're so close. The problem is, how do we log those assertions? One of the ways to do it might be GitHub hooks. We can take the assertions, hash them, attach them to Git commits, and then not allow Git commit until the hashes match. So if the monkey kind of touch the assertions or messed with assertions, it won't be able to commit the code. That sounds like a good idea, but the monkeys are getting smarter and smarter. Now monkeys know how to run git commit and bypass GitHub hooks, which is very, very disturbing. They learn from humans, so obviously. So we can build layers of defense around our assertions. We can say pre-commit hook is a good start, but also we can add rules to the context of our LLM, never touch assertions. And then we can say, okay, we can put it into system prompts, never touch the assertions. And then we can use hooks of the LLMs themselves. For example, pre-tool use hook in Claude Code that will compare the assertions and won't allow the commit operation even to commerce if the assertions were touched. And we can even verify those assertions on the server side in our CI when our CI is running as a different level of defense. So we should put a lot of effort into making sure that the assertions are not touched, because this is the only way we can get away with workable software without reading the code. And I remind you, you don't read AI-generated code, even if you tell me you are. I know you aren't, right? So prompt, created by humans, verified by humans. Spec, created by monkeys, verified by humans. Test, generated from the spec, deterministically, no monkeys involved. Code, written by monkeys, but verified by comparing the assertion hashes, and it means that the code is verified truly by tests. So this is what is called intent integrity chain. It's a chain that verifies that the intent that we had in our heads before we start writing our software definition documents, our PRDs, is actually verified to be implemented in code. Software definition documents are prompt. LLM creates the specs. Everybody read the specs and approve. This is where your naive spec-driven development stops. And then algorithm generates the tests, not monkeys. And then LLM implements the test with verified assertions until they pass. Okay? So why does it work? Because everybody writes text, software definition documents. Specs are readable by all, so they are reviewed by all. Software definition documents and specs are now living documentation. They are not written maybe once. If we want to make a change, we go back to the software definition documents, to PRDs, make changes there, and run the entire chain again to regenerate the code to whatever it's needed, and everything else is derived from the specs. And obviously, all the code is verified by machines. Nothing is left to human code review that we don't do, nothing is left to monkeys because we shouldn't trust them. So intent integrity chain is what behavioral-driven development was intended to be 15 years ago. The technology wasn't there when Martin Fowler envisioned that, right? So we all define and agree on intent. We verify everything that AI does, and we don't trust AI for what we don't or we cannot verify. And it generates consensus. The blame is now gone. Because once the spec is verified by all, we know for sure that what is going to end up being produced is exactly what's in those PRDs. And if there is a problem, the PRDs are not clear enough, and we are going to go back and fix them. And the features are verifiable back to the requirements. And I will show you a demo in a second how you can look at the feature in the application and say, okay, this is the requirement that actually dictated that, and that's very cool. And now we can suddenly start trusting AI-generated code. And you can ask me, is it a reality? And I can tell you, yes, it is. And I'm going to show you what is called, and where is it? Let me find it real quick here. Where is my here? Okay, so this is a dashboard of Intent Integrity Kit. Intent Integrity Kit is the implementation of Intent Integrity Chain, open source on GitHub. The link is in the resources, and it has a visual dashboard that shows the entire chain. And we can see here how we start with what is called the premise and the constitution. This application is a flight search application. And it works and it's live and implemented with Intent Integrity Chain. Once we have the constitution, we all write the spec. And you can see here the spec is built from like a story map. Priority, one-way flight search. And you can see here this flight search, and you can see how the requirements are all connected to the function, how the specs are connected to functional requirements. Library must return all the results, or library must parse flight car data exclusively. And then once we have the spec here, we can go to planning. And planning is a technical implementation. So you can see here the architecture, and you can see here the selected libraries that we selected for implementation of different parts and what's not. And the interesting part here is the small Q&A. Small Q&A here are clarification sessions. And we can run those sessions for every step in the chain and go back and forth with LLM clarifying stuff that wasn't clear for the model. And you can see here, for example, on the spec level, should the library validate date horizon client side or let upstream decide? Or no result, is an error or a valid result? It wasn't clear in the spec, let me clarify it. And you can run those spec and QA on every step of the way. Here are technical questions. Should timeouts be configurable via API? That's a legit question. I didn't think about it. Model asked me. And then for tests, should stand config be applied pre-context or per browser instance? Technical questions about testing and what's not. And here, once we have the spec, then we generate the tests. And you can see the test pyramid, the acceptance tests that are here, and then all like every type of test. And they are all directly connected from one side to the requirements, to the spec, and in the other side to the tasks, to actually code that is going to be written. So we can look here at the test, what it is, concurrent search is something, and then we see the functional requirement, library must support concurrent searches, and we can see here the implementation, write concurrent searches. That's like the code that is going to be written. And implement is a Kanban board that will show you a live progression of the implementation of your feature, and again, every requirement here is broken by tasks, and every task here is tied back from the code to the tests to the requirements. That's the chain that is always observable for you, and you can always look at what's going on. Now, does it mean that you won't have any bugs? All the features will be implemented perfectly or something like that? Obviously not, because even after all this process, with the specifications, with the clarifications, with everything, there will still be features that you didn't think about, LLM didn't brought up, it didn't pop up during implementation, and it just didn't do it. Features are missing. Something doesn't work as you intended because you never expressed your intent. But what it does do, it gives you visibility of what you did intend, how it converts to code, and back around. So, I'm out of time. Okay. So this is the project, it's on GitHub, the link is in speaking.jbaruch, and that's exactly what we talk about. And what it actually means is the code becomes your new intermittent language. The code is the new bytecode. It's, for now, a little bit less stable than bytecode because it's generated by non-deterministic monkeys, but with the intent integrity chain, you can actually trust it more. Not absolutely like you trust bytecode, but more. And basically, three things to take away. Every abstraction leap starts with failures and ends with progress. We are in the middle of such a leap. It was the same with DevOps, with cloud, and even with compilers back in the 50s. It was always the same notion. Hey, we cannot trust this layer anymore, but eventually it transfers to progress. Never trust a monkey, as I mentioned. Whatever is generated by LLM must be verified and validated either by reading humans or by algorithms. And intent integrity matters. This is how you produce it. So software-driven development doesn't have to look like that. We can actually bridge the second part of the gap by doing the verification that we need. Stuff to try on Monday morning. Take one feature from your backlog of your pet project or anything like that, and then write a spec in English, in French, or in German, whatever your language, and run the integrity kit. Let me know how it went. Did it break for you? I will be very happy to fix it so it will work for your case as well. So yes, when I see Mistral renaming it to Vibe, I'm going like, what? People, vibe coding in 2026? Not a great name. Go back to Le Chat. It was absolutely adorable and not going to happen, unfortunately. All right, that's all. QR code for speaking.jbaruch. I'm at jbaruch everywhere. Talk to me about context engineering. That's kind of the most important part of everything that I talk about. Voxxed LU, intent integrity chain, and speaking.jbaruch. This is where you find everywhere. The QR code points there as well. Thank you very much.